KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Hi, welcome to Homework Hotline. I'm Ken Pinkerton. I'm a retired science teacher from Zane Middle School.
And my name is Rita McConnaughy. I'm a math specialist with Northern United Humboldt Charter School, and you're watching Homework Hotline. Thank you for joining in.
Yeah, definitely so. So we're here to hopefully do some fun demonstrations, and we talked to some teachers and tried to get some of their curriculum that they'd like covered. So today we're going to talk about density and buoyancy. So why things float and sink, basically. So this is a fun demonstration right here. I've just got a container full of corn, feed corn.
Okay.
And I'm going to put, this is a pretty heavy ball.
Does it have a bell in it?
Yeah, it's a little dingy bell inside.
That's really cool.
And then this is a pretty solid one, so it's very heavy.
That's
and
like
then
a big
golf ball.
Okay.
And then I'm going to have you, so what's nice about this is it's a medium, and because it flows, it's actually considered a fluid.
Okay.
So we're going to see what happens if you agitate it.
Okay.
So
even though it's corn, you consider it a fluid?
Yeah, since it'll flow,
okay.
It's considered a fluid. So
and you want me to shake it, right?
Right.
Okay,
right.
So we've got the 3 balls in there. Do we have a headshot so you can see me shaking it? Or a
overhead shot.
There they go.
So
you want me to keep shaking it?
Yeah, keep shaking.
Oh, I hear the jingle.
Yeah.
Come on. Go underneath.
So the heaviest ball sank really fast. So keep going. Oh, you're almost there. And then
what's that?
So we had an egg that popped up.
Ah.
So keep going. Another egg.
That's cool. Anything else?
I think there's one. Oh, there it is.
And a ping pong ball.
Yeah, and a ping pong ball. So what happened is that, I think that's it.
That's kind of cool.
We go back to these guys. That one sank. This one kind of stayed right in the middle. So or
the
kind
golf
of stayed
ball?
on the surface.
Yeah,
right?
I couldn't get it underneath.
These guys popped up, and this one.
This is more fun than an Easter egg hunt.
And then this one we didn't pop up, and it's filled with corn.
Oh, okay.
So it's kind of neutral, so it would kind of stay right where it was. So you want to try it again?
Yeah.
Okay, so we're going to sink these guys.
Did you do this with rice?
I haven't done it with rice. You could do it with rice.
Okay. I'm just thinking about something at home.
Oh yeah, you could do it with anything that will flow. And it's considered a kind of a liquid because I can pour it, it'll flow. So I'm going to sink these light guys.
Same properties as a liquid would have.
Yeah, definitely so. And this one, the pink one, is full of corn, so we'll see if that one comes up or not. And we'll put the heavy ones on top. Probably just 2 heavy ones on top. Which one do you want to?
Well, I like the bell
one. Because you
one.
can make sound with it, right?
Okay, and then I'm going to put the golf ball again. Okay. And then my goal is to get the heavy ones to sink, and then
we'll see what happens.
Then the surprise ones to come up.
Okay. And then this is all in buoyancy. So if they sink, it's called negative buoyancy.
Okay.
And then if they rise, that's called a positive buoyancy.
Buoyancy.
Yeah, buoyancy. Buoyancy. So those are.
Come on.
Sinking. There we go. Sometimes they kind of get in each other's way.
Did you put corn in the wall?
No. Okay, those 2 both came out again.
This is a workout.
We can touch the buoyancy exercise routine. We got a new routine. That's probably good. It's in there. So this one just stayed in the middle because this is the same density. And what density means is it's the mass per unit of volume. So if something is very heavy, like comparing these two, I tried to find 2 balls that were the same. So those are approximately the same. Let's see if I can find the other one.
I'm kind of thinking like in a grain bin, if you stand on top of the corn, would you sink too?
If you move
a lot?
Yeah, if you move a lot, then you would. But
is that kind of like in quicksand, they say not to move?
not to move around so much. So, right. And then we'll talk about snowshoes.
Maybe those are just in the movies.
Yeah, that kind of thing. So these are approximately the same size.
These two?
Yeah, but this one is the weight difference is significantly So if I put them on the scale, we can do a quick,
Oh,
we'll discount the lids, okay? But we'll just put them in, compare. And you can see that one's
Wow.
a lot heavier. So it sinks a lot faster and then this one is even heavier. So let's compare those two. I'm going to just take these out.
okay.
And watch how fast they sink.
Okay.
And it's because of their density. So they're about the same size. So you can see that one went down very, very fast. So, and then the nice thing about the corn is it's a little bit slower than if I put them in water. They
both
go
drop.
very, very quickly. Yeah, so they float or sink. And then so there's a neat formula I wanted to write.
I'll get that up for you.
Way I remember the formula for density is it's I love density.
I heart density.
I heart
okay.
density, right? And then if I take this and I draw, I'm going to put the heart better, okay? If I draw a line through it,
Okay.
then that shows me the formula. So it's M. Oops. I'll draw it this way. I'll make it like the heart. Can I erase? Let's see if I can erase. I'll do a better job.
I think it looks okay. The
Is it
M,
okay?
you mean?
Yeah, because I want it to.
Ah. We should have had our pen be red
Okay, I'll
for
do
the
the
heart.
red. Yeah, that's true. Okay, so if I do M and then V, and then that's the formula for density. So equals density. And M stands for mass, which is, and then this is volume. Okay, so mass is how much something weighs, basically. It's the pull of how much stuff it has in it. Yeah, you get right, mass. And then volume is how much space it takes up, basically. So yeah, there's volume.
There we go.
So that's a neat
How's
way to
that?
remember mass over volume. So
It's a
and then
line
on
through the
Thursday,
heart.
I think we're going to do some calculations of seeing how things float and how they sink. So
the heavier ball had this was the lighter ball, right?
right.
The heavier ball had a greater mass.
Mass, right. And then so it has a greater density too. So, and then we do the same thing if this was about the same size. They have, the volume's approximately the same, how much space
Okay.
they take up. But the mass, that has a lot, it's steel, so it's got a lot more mass in it.
More mass.
And
Kind of like thicker, or if you say something is more dense,
Right.
is that what you're talking
yeah,
about? More dense?
It's more heavy and things like, there's the old kind of joke, which would you rather have dropped on your head, a pound of feathers or a pound of lead? And
A pound is a pound?
yeah,
is that
a pound
right?
is a pound, and the answer to that is density, right? Because if I drop this on your head, it's going to be painful,
Right.
Because it's very dense. But if I took a pillow, which weighed the same, and I dropped it on your head, because it's a much bigger volume,
Gotcha.
then it still weighs a pound, right?
Okay.
But the space that that pillow would take up.
Okay,
It's
so
gotta
having
be-
it drop on your head is one thing, but how about if you drop it from the top of a building and will it fall the same rate
On the moon, it will.
on the moon? Okay.
But the feather, the pillow would catch the wind and things like
Okay.
that. So we can do, and then I think we'll wait till Thursday to do the math of it.
Okay.
With the different densities, and then so one key thing is probably the most famous thing is water for things floating and sinking, and so the density of water is 1 gram per cubic centimeter.
Okay.
And what's neat about that is the whole metric system is basically based on that.
Okay.
That 1 gram is cubic centimeter.
I might write that down.
yeah.
So you,
And so if something is more dense than 1 gram per cubic centimeter, it sinks. And if it's lighter than 1 gram per cubic centimeter, it floats.
okay, so you said water, right?
Right? So pure water, but that's okay.
Pure water means nothing else is in it, right?
Yeah, absolutely. Yeah.
Okay, and you said it was what, 1
It's
gram?
1 gram per cubic centimeter, or centimeter cubed.
For 1 centimeter cubed, right?
Yeah.
And that's its density?
That's the density of water. So
Okay. Oh, I gotta spell density,
density
correctly. Hold on a minute. Mwah.
There we go. Density.
Density of, and I'm gonna put H2O.
Good.
How's that?
That's much better. So, and
Okay.
then so like I said, if it's more dense than this formula, 1 gram per cubic centimeter, it's going to sink. And if it's less dense than that, and then sometimes it can be real surprising. Because most of the time, I'm going to take my ducks out and put them here. If I put water in, or a wood,
wood block,
a wood block, it's going to float.
Okay.
And that one, and then the other thing is the higher it floats, the less dense it is. Okay, so if you look at that one, it floats pretty high in the water. And let's try, this one's oak. So let's see, that one's quite a little bit. And then this is a wood called Lignum Vitae, or also called ironwood. And you'll see why.
Wow.
It's more dense than water.
Wow.
So it's a wood that sinks.
So it must have a lot more mass.
Yeah,
per
it's
volume.
very, very dense.
Can you say the name again?
It's called Lignum Vitae.
Lignum Vitae.
And then, or
That's the kind of
ironwood.
wood.
And we have in California, in Southern California, there's a plant called Catalina Ironwood, and it's also really dense like that. And then I'm trying to find my other piece here, so hold on.
Okay.
Get it out of my box.
I'm going to try to grab that ironwood and see it go down one more time.
Okay.
It's crazy how the light-colored one is just floating there.
Yeah.
You said that was oak?
I think that's oak, yes.
And then this nickname is ironwood.
Ironwood, right. Yeah. And then here's a rock. You want to
Put the rock in?
Yeah, put the rock in.
Won't it just sink?
What do you think?
Well, it's pretty porous.
It's very porous, right?
There's a lot of holes in it.
Right, and so it's got a lot of air in it.
A lot of air, okay.
Yeah, so that's pumice from a volcano. It's a very, very light, so it's kind of a compact ash. And so it's odd here. So usually we think of wood floats and rocks sink, but this is 2 cases. And the reason that the difference is density, is that one is more dense than 1 gram per cubic centimeter, and this is less dense than 1 gram per cubic centimeter.
So here, you could make a ship out of pumice, but not out of ironwood.
No.
Huh?
Well, it depends on the shape. That's the other thing.
I suppose.
But yeah, usually ironwood would be a really poor choice for for wood construction. So there's a neat toy, and then in real life, I think if we have a graphic of a fish with a swim bladder, if we could ask to pull that up. And then one of the ways that some fish control how they go up and down is with a swim bladder. And inside the fish's body, they have, it's a bladder, which is just a sac. And the fish can actually make that bag smaller or bigger. And as it makes it bigger, it becomes less dense, and so it'll float up higher. And then more dense.
Is that like a blowfish, or is that different?
That's different, but it's kind of the same principle, except that the blowfish can make its whole body do that. So it looks more...
Where the other fish just has one part inside its body that blows up.
Right, and it makes it less dense. And then these are, and then the other thing that people have done the same things with submarines.
Okay.
Inside a submarine, there are big tanks that are called ballast tanks. And what we're going to do is take the lid off of it.
Take the lid off the submarine. These are little submarines. I use sub numbers in my math class.
Oh, cool.
This reminds me of Battleship. This isn't a Battleship.
It looks
game,
kind of like
it?
those. And then I'm putting I think this is baking soda inside here. Okay.
Baking soda,
You
okay.
want to put some in yours?
Sure.
And then we're going to put the conning tower back on.
What'd you call that?
Conning tower? This top part is called the conning tower. I don't know why. It's called
Conning with
conning.
a C, or?
Yeah, maybe for reconnaissance.
Okay.
So yeah, C-O-N, okay? And now I'm going to drop it in here, and we'll see what happens. So there it goes, it's going
sinking.
down. So it took on more water,
Okay.
and so it became more dense.
Is that what it was supposed to do?
Yeah, and then we'll hope the magic happens here soon.
Magic?
So put the conning tower
Well,
back
I don't
on.
want to miss that.
And we'll see.
Okay, so you put baking soda inside.
Right.
All right, I got to catch up to you.
Just put it there and we'll see. So right now it's less dense than water, right?
Less dense than the water. Oh,
Yep.
I don't think this thing got on quite right.
Okay.
Less dense than water, and that's why it floats.
Right. And now you saw the bubbles and some stuff go down. So it's not even keeled. Oh, there he goes. It's okay. And then while we're watching, it's okay. It'll go.
I know. I want to put it on that side.
Oh, on that side. Okay. Well,
It's gonna go check out the pumice rock
it's hit
and the oak,
hit the pumice.
and then it's gonna realize it.
We'll take that. Whoops, the duck fell. And then these are a really neat toy. They're called Submergibles, and they're a pool toy. And they're sealed inside, so there's a little air pocket inside. I can actually open it up and show you. And you can do yours. And then it's a pool toy because you can throw it in the pool or a river. So it's got an empty space with a nice seal there. And if I crank it all the way down.
Can we put corn in here? I'm kidding.
We could try.
Just kidding.
We put it all the way down and I let it go. Then you'll see it sinks.
Okay.
So if you're playing in your pool, okay. But the other neat thing is, now I'm going to take it and I'm going to open it up bigger. And so what am I doing if I'm making it bigger? I'm increasing its.
You're increasing its volume.
So the volume's getting
more space
bigger.
Inside.
And did I make it heavier?
You didn't make it heavier.
Okay. So if I don't make it heavier, and then I'm going to put it in there, and it floats.
Oh.
So by making the volume bigger, and yours, it looks like you're coming up for.
What happened?
Yours is coming up. Mine's sunk.
What's wrong with yours?
I don't know.
I missed it. When did it go down?
Yeah, almost immediately. So we'll see. I might have put in too much power. We'll watch it and see. Maybe it'll be activated. So, but these are neat because they really show that without changing the weight at all, just by changing the volume, I can make something float or sink.
Change the space inside. So mass stayed the same,
Right.
mass, how heavy it was.
Right.
But the volume was greater. That meant that it was less than 1
gram per cubic centimeter.
gram
right?
per
Right.
cubic centimeter.
So, and then you might have seen the other neat thing is if you go to the Great Salt Lake or go to the Dead Sea in the Middle East, it's very, very dense because there's tons of salt water in there. Looks like you're maybe going to go down.
You're talking about my submarine?
Yeah, your submarine.
Why did it go up?
It hasn't ever gone down yet. So I think it needs some. I'm gonna.
Did I put too much baking soda?
Maybe so. We'll see. I might have put in too much too.
Or maybe I sealed it too much.
We'll see what happens there. And
It's
then sometimes
smoking.
they take a little bit of time. So. But these are neat toys, and again, what happens is that the baking soda that we put in there is going to react with the water and create bubbles, and that's going to push some of the water out,
Cool.
and it makes it.
You know what I like about the pool toys is that if you are not used to going underwater yet, you can still play with them,
Right.
right?
Yeah, they're
Because
really
they
nice, so-
float.
Yeah.
But if you're a diver or you want to practice going under the water and get the pool toy,
Right. Oh, there you go. You're sunk. Then yeah,
then
you can
the
do
one
that,
with
so.
less volume would go
Right.
to the bottom. You could find it. Okay,
Yeah.
the submarine went down because the baking soda was activated.
Yeah. Well, no, the water got in. I think.
Water got in,
Made
ate
it
the
more-
baking soda.
Made it heavier, and then so we're hoping it'll work. So, and
How-
then another thing that works.
I
on
have a
this,
question
okay.
though. How does that relate to the fish bladder?
Well, what happens is that the air gets bigger and it pushes the water out of the way. So kind of in the same way that it just changes the density. And the way it's changing the density, the size doesn't change at all, but air bubbles develop with the.
And then on a real submarine,
on a real submarine, they actually pull in water.
they pull in water when they want to
Right.
sink,
Uh-huh.
go down,
And then they use air to blow out the water.
let out the water to
Right.
come up.
Yeah.
Okay.
When they do it fast. So it's called So, and then another thing that we see is this
guy?
is called a Galileo thermometer,
Galileo
Yeah.
thermometer.
and it works by the water is sealed in here, but you'll see when it's warm, it has a lot of area to increase the volume of it. So on a cold day, this water is going to be smaller and it's going to be more dense. And that's going to push up more of these little weights. So these are really, really finely calibrated weights.
So this one says 82 degrees. Does that mean that's the temperature?
Yeah, I think it's off a little bit.
Because it is not 82
not 82
degrees
in here,
outside.
So, no, it's not.
It's a cold, windy day,
I'm
actually.
going to gently turn this and see if I can mix them up a little bit. See if they float. If I do that, they might have been. So
Galileo thermometer.
yeah, Galileo's thermometer.
Is there one broken, or is that just?
Might be. I don't know. Yeah, that might be the problem. Is that something stuck in there?
One got broke.
Yeah. Oh, it is. Yeah, one of them, and it's pushing down on the other
The top
side.
is
Right. Well, let's try it this way. I'm going to just do it gently. Turn it over and let's see what happens.
okay.
And then we might get a better temperature. Yeah, because one of them broke. And so now the way you read this is the lowest one is supposed to be the air temperature.
Oh, not the highest, but
No,
the lowest.
Yeah, the lowest
That
one is
makes
supposed to
sense.
be, yeah, so,
Gotcha.
so now it says 75, but if we leave it there, we'll see what happens on them.
So
But each one of these is just a
72.
teeny bit less dense than the other ones. And so as the water becomes more dense, they sink, and then that's supposed to tell you the temperature. So, and there's no way I can get that broken one out of there. It's sealed in there. So, but but that's another example of using density at work to show. And then I brought in this lava lamp, and it's doing the same thing.
Now these were big in my day.
Yeah.
I remember lava lamps. They were kind of a different shape.
Right. This one I brought in because it works really fast. Where a regular
It's
lava
really
lamp.
hot. Is that because of the
Yeah,
the
the
lamp?
lamp is underneath it. It's heating. So what's happening here is that the light, like you said, is quite hot, and it heats up the fluid, and it expands. So if it expands, it becomes less dense, and it gets pushed up by the more dense. And then as it cools up here, so here you can touch it. Here, I wouldn't want to hold on
I
to it
could
very
watch that for a long
it's-
time. It's like relaxing.
It's very,
so
it is
in
nice.
the center, it's going up.
right, where it's hot. And so the hot stuff is less dense and it's going up. It's actually getting pushed up by the cold stuff that's coming down. And so it's a convection cycle, basically.
So hot or warmer in the middle, going up.
Right.
Warm air, like warm air rises, warm water or liquid rises.
Yeah, they're pushed up.
And then
when
down the side is the
cooler
colder.
stuff, right? And then they put this. You'll notice all lava lamps usually have an aluminum cap on them because aluminum transmits heat really well. So that's quite cool.
That
compared
is.
to down here, it's hot. So another example of expands, less density, gets pushed up, and then cools, contracts. And
I don't know if
goes
this
back
will
down.
fit in my pocket to take. Just kidding.
And then
That's
there's
pretty.
a neat. Oh, and we'll do another one here.
Okay.
This
Oh, I
is another
love
example
this.
of we can start talking about some other.
Our submarines rose.
Airs. Yeah, they did. Yes, I
So-
knew that they would. So yeah, so
How did
while we
that
weren't
happen?
looking, so the air inside expanded. There was a reaction with, and you can see this little one on.
So the baking soda is like coming out the
Right,
bottom,
yeah,
like
so-
it's a fish.
Yeah, so it's taking on more water probably, and little air bubbles are leaking.
and then
out
it'll
from
sink again,
They'll
huh?
sink again,
Okay.
right, so, and then here's another one. You
Oh, I
can-
like this. This is
The-
where hot air is going to rise, right?
Right.
Now, what does this have to do with
And
density?
then, and then what's happening is the air gets hot, so it expands.
Let me do that one
You
while
wanna
you're
try it?
explaining.
And then the concept of things actually rising is not true. Is that the reason that things go up is because they're pushed up by things that are less dense.
Oh, this is
Or
such
more
a cool
dense.
thing. This is a German
Yeah.
tool.
So what's happening here is that this is heating the air up. Excuse me.
So that the warm air is rising.
That warm air is rising. I'm going to tilt these in a little bit so that
Okay.
we can get the air more concentrated without setting my little building on fire. And then as the warm air rises, because it's less dense, it's pushed up, and then in the process of being pushed up, it pushes on the veins, and it makes our little guy, our little
The little
Spinners.
singing, the
Yeah.
singing monks,
the
or
monks, yeah, it looks
something.
there.
Very
So-
cool.
So you often see these in around the
The
holiday, Christmas
holidays,
times.
yes.
And,
That's when I would bring mine out.
Yeah. So, and then this is a neat one that that surprises people. Is that well, I'm going to bring out my milk.
Are
one
you a
first.
Coca-Cola drinker?
No, I.
No? Okay.
This is an old milk bottle, And I don't know if you grew up in the Dakotas. Did you have dairies around you?
We had dairies, but glass milk bottles was before my time.
Okay. so this is a special glass milk bottle. And if you were lucky, or if you still are lucky, that if you get non-homogenized milk, you get this, the cream will rise to the top. And so you always wanted to be the first person to open up the milk. And then this one was really neat because cream is less dense.
Okay.
And so it floats above the milk. And so this has got a cool little reservoir that would actually capture the
would capture the cream in here?
Yeah.
Kind of like a gravy separator.
Yes, very much. I got one.
Collects the fat from the gravy on top. Like you pour the juices in here and then let it sit. Did you want to explain this? I'm sorry.
No.
So this is I know about this. Okay, so the juices sit, the gravy or the fat comes to the top, and then when you pour it out, you can't really see it, but you pour it and the fat stays on top because the spout to come out is here. So the juices that you want to make gravy come out and the fat stays on top. It's genius. Yes. I love it.
And then one way you can kind of show that too is that if you get regular oil and vinegar dressing.
Are we having salad?
Yes. That you'll notice this line right here. It's a very clear line between the oils on top, so it's less dense and so it floats. So even if I shake it up like crazy, you'll see that it'll take a minute and all pretty soon.
We should do that at the beginning of the show next time.
Right. We'll
shake it up and then, like our submarine that sank.
It's going.
And we weren't.
So, but this is the non-fat stuff, which means it has no oil in it, and you'll see that there's no separation because it's all homogenized in the same material.
So that tells you what kind of dressing you want.
Right.
If you want the non-fat or the one that has fat in it, if it separates, it has fat in it.
And then these are some cool toys.
Oh, you have so many cool things for density.
Same things that, if you look at this one with the penguins, they're floating on this little layer.
Okay.
And it looks clear, and they've colored it. And then these spinners have a heavier liquid on the bottom. So if I turn them over, you'll see that the lighter and the air bubbles go to the top, and the liquids will go to the bottom.
Who knew that so many toys had so much science in it?
It's all science, right? So these are cool ones. So
what was the Diet Coke?
We'll do it on Thursday.
Thursday.
So we're running out of time. So we'll talk more about density and bring some more math into it on Thursday. So we'll be here.
Heart, right?
Yes,
I heart density.
I heart density. Yes, definitely. So maybe I'll get a tattoo over.
An I heart density.
So I'm Ken Pinkerton.
And I'm Rita McConnaughy. Thanks for watching.
Thank you. Bye-bye.
Bye.